Question 3A is saying a speedboat moves from rest to a velocity of 30 meters per second in 5 seconds. It then maintains the velocity for a period of 4 seconds before coming to rest. Given the retardation as -4 meters per second squared, draw a velocity time graph for this motion and determine the distance covered. Draw a velocity time graph for this motion and determine the distance covered. So I want to be referring to these same values which are here. So I won't go to my blank board. Instead, I'll draw the diagram just here. So I'm going to put up my X or Y plane like that. So note say here there'll be velocity in meters per second, and here there'll be time in seconds. Okay, this is the Y, this is the X. So they've told us to say it is starting from rest, which means it's starting from 0 here. And it is going to a velocity of how much? Of 30. So I'll put my 30 somewhere there, like that. So from 0 to 30, and how much time duration is this happening? This happening in 5 seconds. So I'll put my 5 seconds somewhere there. So that means in 5 seconds, it reached a velocity of 30, which means my line will be like that. That is my first part of this movement, like that. Then it maintained this speed for 4 seconds, which means on these 5 seconds that I have here, let's add 4 seconds. It is going to give us what? 9 seconds. So since time is not stopping, time is constantly moving to somewhere where there is 9 there, the velocity was the same. So which means to where there was 9 somewhere there, the velocity was maintained. So I'll put a straight horizontal line like that to show that for 4 seconds, the velocity was constant. Then after that, it started decelerating, came to a stop. And they've told us to say the rate at which it was decelerating was -4 meters per second squared, like that. Now, for us to find the time here, because we know what to say here, the graph will just go down like that. But what is the final time here? So for us to find the final time here, we are supposed to find the time taken for this retardation. So we know to say acceleration is equal to final velocity minus initial velocity over time. And we want to find time. So we'll cross multiply there, and we're going to get AT is equal to V minus U over A, that means A is cancelling out. So time is equal to final velocity minus initial velocity over time. So what is the final velocity? The final velocity is 0, since it's coming to a stop. So 0 minus, what is the initial velocity? It is 30. So 0 minus 30, it is giving us -30 over, what is the acceleration? It is -4. If I divide -30 divided by 4, I'm going to get time, which is equal to what? Time which is equal to 7.5. 7.5 seconds, which means this is what the total time taken for this object to come to rest. So on the 9 seconds that I already have, I'm going to add this 7.5 seconds. And what is it going to give us? It is going to give us 16.5. So which means the time here at the end point, I'll clear this guy. The time here at the end point is 16.5 seconds. And that means that was the total time taken for this journey. So this is the velocity time graph of this car. I'm done with the velocity time graph. Find the distance covered. Okay, so for us to find the distance covered here, we are going to find the area under this graph. And since this is a trapezium, we're going to say distance is equal to half the formula for finding area under a trapezium A plus B h then. This will be equal to half. What is our A? It is the distance from here up to there, which is what? Which is 4. Plus B, the distance from here uh, uh, up to there, which is 16.5. Then the height, which is 30. This is going to give us what? This is going to give us, in the brackets, we'll get 20.5, 20.5 multiplied by half or 2 into 30, this is 15. And this is going to give us a total distance of how much? A total distance of 307.5 meters as the total distance covered for this journey. So that was all on question A of question 3. Question 3A, that was all. That is the velocity time graph, and that is the total distance traveled. Let's go to question B. Question B is saying a Mini Cooper, that's the name of the car, a Mini Cooper of mass 1400 kilograms is traveling at a speed of 108 kilometers per hour and travels a distance of 45 meters before coming to rest. Determine the magnitude of the net force required to bring the machine to rest and state the direction which retards and states its direction with regards to the initial velocity. Whew. Okay, so we can go to our blackboard now. And this is question 3B. So on question 3B, we've been given the velocity of 108 kilometers per hour, like that. Then we've been given the mass of the car to say it's 1400 kilograms. What else do we have? This guy is coming to rest, which means the final velocity is 0. So what are we supposed to do first in order for us to find the force? Let's find the acceleration of this vehicle. Or in order for it to move from 108 kilometers per hour to 0, what was its acceleration? And to say, in order for us to do that, first we have to convert our final velocity, the initial velocity, which is this guy, into its SI unit, which will be meters per second. And 108 kilometers per hour is equal to this is going to give us how much? It is going to give us 30. All right, yes. It is going to give us 30 meters per second, like that. So let's find the acceleration of this vehicle. The acceleration will be found using this equation. V squared is equal to u squared plus 2as. Why? It's because we have the distance covered. They've given us to say it's 45 meters. We're looking for acceleration. 2 is a constant. We know the initial velocity. We know the final velocity. So final velocity is what? 0. 0 squared is equal to the initial velocity, 30 squared, plus 2 multiplied by a multiplied by the distance, which is 45 meters, like that. So what is 30 squared? 30 squared is equal to 900 plus 2 multiplied by 45. This is 90 a, like that. We get this 900, we take it to the other side. We're going to get 90a will be equal to negative 900 over 90, given this side over 90. I'll cancel out the 90. A is equal to 10 negative 10 meters per second squared, like that. So that means the deceleration of this vehicle was negative 10 meters per second squared. And since we found the acceleration now, we can bring in our Newton's second law of motion to say force is equal to mass multiplied by acceleration of which this acceleration is equal to this guy that we are from finding. So find the magnitude of the force. This will be equal to the mass. What is the mass? The mass is 1400 multiplied by the acceleration, which is negative 10. The force will be equal to what? To be equal to 14,000 newtons. And this will be a negative force. Why? It's because it is, oh, I'm trying to answer the last question. So if this is the force now, sometimes maybe some of you would just write it with a positive value, but this is a negative. So it is okay to show it with a negative, but since it's a force, either way. So what is the direction of this force? This is the force that causes this car to stop. This is the force that brings this vehicle to a stop. Now, what is the direction of this force? It is opposite to the direction of the initial velocity. The direction of force is opposite to the direction of the initial velocity. So I've answered both questions. One of them was asking us to determine the magnitude of the net force required to bring the machine to rest and then its direction. So the magnitude is 14,000 and it's directed. It's a negative force since it's bringing this object to stop and it is directed opposite to the initial velocity. So that was all in this paper. That was all in this paper. And finally, I can say I'm done.